Hello, good morning, students. Good morning, all of you. Yeah, good morning, all of you. Come on, join first so that we can start our class. I can see Section Darnal, then Aryan Shah, Priyansh Kumar Thakur, Pragyan Chetri, Tavabrata, Maitri Chanda, then Amisha Agarwal, Sahil Sharma, Subhendu Mandal. Yes, Sneha, good morning, good morning. Pratham Roy has also come, but he will get banished after 2 minutes. I know. Now he has written his name. After 2 minutes, he will get vanished. Mritik Dev has come. Sneha Lama. Yeah, at the beginning, who has joined? Let me mention their name like Jasraj, Subhoma Roy, Ratul, Amisha, Sahil Sharma, Mati Chanda, Tapabrata Ghosh. After that, Pragyan Chetri, Priyansh Kumar Thakur, Aryan Shah, Saksham Darnal, Sneha Chatterjee, Namrata Bose, all okay. But where are the others? Other students are not there. Shreya Kumar, I can see. Pratham Rai is saying, sir, today no Mr. India. I'll be there throughout the class. Pratham will stay with us throughout the class. Let's see. Pratham will stay with us throughout the class. Let's see. Let's see. Fine. So get ready. We'll continue our chapter. The chapter which was going on electromagnetism. The chapter is electromagnetism. Okay. Uh, the chapter is electromagnetism. We know that we started that chapter, but students are not there. I can see only 13, 14 students are there. Where the rest of the students? Rest of the students are not there. Rest of the students are not there. I don't know where the others. Okay. I'll take the attendance in between. The attendance will be taken in between. Let's see. But I can see only 12, 13 students are there in the group. Suprabhatam has come now. Kesang Tamang also I can see. But where the students I don't know where they have gone. Okay. Let us continue our thing. And in between I'll take the attendance also. And I'll mention your name. If I am not getting the response from your side, that means you are absent. Okay. I will mention your name in between. Understood? Oh, one information for you. Okay. One information is that Thursday will have CP, class performance. Okay. CP. Thursday. Understood? Don't forget Thursday CP and CP about CP. The chapter is electromagnetism. This chapter. Understood, all of you? Thursday we will have CP, and both the CP will have CP1, CP2, 20 marks. Okay. Acha, forget about first 10 marks. 10 marks CP. Uh, 10 marks CP. No, we can conduct it together. 20 marks. No problem. 20 marks CP can be conducted. Okay. Uh, 20 marks or 10 marks? I wasn't thinking. No, no, only one CP. CP1. Okay, CP1. Actually, CP1 marks is I adjusted the marks of CP1 from the project, like from the things that homework and class of which I keep telling you that you send me. I will check those. Means after showing you a video, I tell you that what are the sums mentioned in that video. Send me that. Okay, I mentioned this type of things. Then actually I adjusted your CP marks from that. But you know what? Maximum students, okay, around 50% students, they do not submit regularly. Sometimes they submit and sometimes they do not. So maximum time they do not submit. So I had to give them like out of 10, 2 or 1 they have got. So it's a loss of yours. So that's why, since you are not submitting, so I'm not giving marks. But now what I decided that not to take the marks from that, otherwise you'll be in loss. So what I'm doing now, I will conduct the CP1 and CP2, and I will conduct that CP1 and CP2 the way I conducted UT1. Understood? The way I conducted UT1, the same way I will conduct CP. So just get ready and uh, yeah, Thursday, 12 o'clock. Okay. This Thursday. Today's Monday, and this Thursday, 12 o'clock, you will have a CP of 10 marks. Okay. CP of 10 marks. Another 10 marks will be taken next Thursday. Okay. This Thursday, 10 marks, and the next Thursday, again 10 marks. And this Thursday, 10 marks, that is CP1. Syllabus is electromagnetism, what we are doing now. Okay, electromagnetism, how much we have finished from that much. Okay, electromagnetism, how much we have finished or how much we are going to finish by this Wednesday. You have got 2 more classes, Monday, Wednesday. Means this today's Monday and Wednesday you have got 2 classes. Okay, and Thursday you will have test. So by this Wednesday, how much we can finish, from that you will have the test. Correct? This is the syllabus. So let us continue our syllabus. So electromagnetism. Electromagnetism, we discussed about, first of all, we discussed about magnetic lines of force. What are called magnetic lines of force? After that, we discussed what are the properties of magnetic lines of force. In properties of magnetic lines of force, just a quick revision for magnetic lines of force. We discussed uh, that magnetic lines of force always starts from North Pole, ends at South Pole. Two magnetic lines of force never intersect. And what is the third property? If you draw a tangent at any point of magnetic lines of force, then that tangent gives you the direction of magnetic field for that point. Okay, these 3 are the properties of magnetic lines of force. Now number 2, we discussed that how magnetic lines of force looks like for a bar magnet. Bar magnet is simple magnet. This is the magnet we already discussed. This is the bar magnet, and this is the way magnetic lines of force goes. We know that, we have already discussed. Okay, now the next is, I can see few more students as well. Nilesh, Raman, Srishti, Nitesh Guria, Suparna Shen, Karan Mitra. Okay, I can see them. But number of students is very less here, because students joins, after that they goes away. They goes away. Okay. Now, almost everybody has joined, but they have written just their name. After that, like half of them has gone. Oh, Nilesh De Biswas, you have not got the notification. Why so? You should get. You have not got the notification. You have subscribed, no? If you have subscribed, you will get the notification. I don't know what is the problem. I don't know what is the problem. Okay. Um, Now, the thing is that, so all these things we discussed. After that, we also discussed an important question, that why magnetic lines of force do not intersect. That is also we discussed. Today, we'll discuss a very important thing. All of you try to understand what I'm saying. Okay. All of you try to understand what I'm saying. First, I'm taking a magnet. Can you see? I'm taking a magnet. Very carefully you listen what I'm saying. Very carefully. This is a magnet. North pole, south pole. Okay. North pole, south pole. Now, this magnet can rotate freely like this. Okay. This magnet can rotate freely. If you see like this, see, this magnet can rotate freely. Okay. Okay. It can rotate freely. Now, just above this magnet, I'm keeping a wire. You understood? Just above this magnet, I'm keeping here. I'm not going to touch it. Okay. I'm not going to touch it. Just above the wire. This is the magnet and this is the wire. Okay. Understood this? Now, in this condition, if you pass electricity through this wire, this is the wire. If you pass electricity through this wire, you will see that the moment you will pass electricity through this wire, you will see that this magnet will be in this position. If you see like this, see like this. Okay, this is the magnet, this is the magnet, and this is the wire. Okay, now if you pass electricity through this wire, this is the wire. If you pass electricity through this wire, you will see that the magnet will take this position. Okay, the magnet will take this position. But the moment you switch off the current, again the magnet will come this position. Okay, again you switch on the current, the magnet will go this position. Okay, this way. Switch off the current, again it will come like this, the magnet. Now you change the direction of the current. Understood? I'm changing the direction of the current. So if I change the direction of the current, then the moment you pass electricity, now the current is going downward. Okay, downward. You'll see that the moment you switch on the current, the magnet will move like this. Earlier the magnet was moving like this. Now the magnet is moving like this. Okay, you switch off the current, again it will come like this. Okay, this is an very important question for your ICSC. Okay, it's a very important. Actually, this is an important question for not only for ICSC, it's for CBSE also. Very, very important question. Okay, here we'll discuss about a rule. About a rule. You might have seen in the title of this video, I mentioned something, that is Ampere sweeping rule. Yeah, it's very important. First, let me discuss this. See, this is the magnetic needle. This is called magnetic needle. Try to understand, all of you. Magnetic needle. This is the magnetic needle which can rotate freely. Okay, I told you, na? This is that magnet. Okay, this can rotate freely. This magnet can rotate easily. Okay, now just above this magnet, so this is the magnet. Actually, the magnet I keep in this position, Just above this magnet, I am keeping a wire, electric wire. Okay. So just above the magnet, I am, see, just above the magnet, I placed an electric wire. But remember, the wire is not in touch with the magnet. Okay. The wire is not in touch with the magnet. Now, in this condition, if I pass electricity upward, this is the direction of electric current. Okay. In this condition, if I pass electricity upward, then you will see that the magnet will move, the end pole will come here. Means this, see, I made dotted lines. I made lines indicates that the north pole will come this direction. Understood? See, the magnet was in this position. Now the magnet will get this position because his north pole is coming this direction. Understood? This way. Now you switch off the current. You'll see that again magnet. Understood? Switch on the current. Switch off the current. Switch on the current. Switch off the current. Okay. So we saw that when you are switching on the current, the magnet changes the direction. Okay. Switch off, again it comes in previous direction. So in this way the magnet will behave. And remember, here the magnet which I am using is called magnetic needle. Means magnetic needle means where the magnet is free to rotate. It can rotate anywhere. So the moment you are passing electricity through the wire, and remember the wire is not in contact. Okay, the wire is not in contact with the magnet. It's just above the magnet. The magnet rotates. Yes, this is the magnet, this rotates. Understood? So here we say electricity upward. Okay, now we'll pass the electricity here. We were passing the electricity upward. Yeah, it's not is paused actually of network issue. I think it is okay now. It is network issue. Okay. So see here, the electricity is passing upward. Okay, the direction of electricity is upward. Fine. Now in the same situation, if you pass the electricity downward, okay, if you pass the electricity downward, like this is the magnet. Okay, this is the magnet, and see, I'm passing the electricity downward. I'm passing the electricity downward. Okay, it's downward electricity. Fine. First it was upward, see, upward. Now it is downward. And NS positions are same. NS, NS. Okay. In this condition, what will happen, you know? In this condition, you will see that I'm showing you the direction of the magnet. See, in this condition, the north pole will come this way. Okay, can you see these dotted lines? These dotted lines indicates the magnet changes the direction. Okay, this was the magnet, now it has changed the direction. Okay, dotted line indicates. Understood? So now, so when the current is going downward, the magnet changes the position, and when the current is going upward, then magnet changes the position in this way. Okay, but remember what I told you, that here the wire is not in contact with the magnet. Okay, fine. Now this is an important question. I want you to write down all about this. You take your physics copy. After that I'll tell you. You take your physics copy. Come on. All of you take your physics copy. After that I'm saying you something, you write that. It's important. Ready? Okay. Right. A wire is just placed, right? A wire is just placed above a just placed above a magnetic needle. Okay, a wire is just placed above a magnetic needle. Full stop. How the magnet will behave? How the magnet will behave on passing electricity? On passing electricity through that wire. Okay, on passing electricity through that wire. Fine. This is the question, important question. We'll write the answer of it. Okay, first of all you draw these two figures. You draw these two figures. After that we'll write the answer of it. Okay, draw these two figures. Come on, fast. First, now you can draw it roughly. Later on you draw it nicely. You draw. Come on, fast. Come on, fast. For timing, you draw it roughly. Okay. First figure, second figure. Understood? Done? Okay. Okay. Now write. Now write it. In first case, the direction of the current is, in first case, the direction of current is from south to north. See here, it's south to north. See, this is south pole, this is north pole. So current is going in the direction of south to north. Okay, so write in this way. In the first case, the direction of current was from south to north. Okay, south to north. And in the second case, the direction of current is, from north to south. Okay. In the second case, the direction of current is from north to south. Full stop. The moment we switch on the electricity, the moment we switch on the electricity, the magnet rotates. Okay. The magnet rotates and changes its position. Magnet rotates and changes its position. Understood? Changes its position. Okay. And the moment we switch off the electricity, and the moment we switch off O double F, and the moment we switch off the electricity, the magnet comes in previous position. Okay, previous position. Full stop. The direction of motion of the magnet, the direction of motion of the magnet, the direction of motion of the magnet can be determined by can be determined by Ampere's swimming rule. Okay, Ampere's swimming rule. Ampere's, Ampere apostrophe S, Ampere's swimming rule. First, let me discuss what is Ampere swimming rule. Okay, all of you listen very carefully. You listen. What is Ampere swimming rule? In Ampere swimming rule, you have to imagine that a person is swimming. Okay, a person is swimming. Which direction he is swimming? He is swimming in the direction of electric current. You got my point? A person is swimming in the direction of electric current, and the north pole of the magnet will move. What I said? North pole of the magnet will move towards left hand of the swimmer. Okay, see now this figure. The person is swimming in the direction of electric current. So in this way, it's swimming in the direction of electric current. So what is the direction of when the person is swimming? Which is the direction of his left hand? Yes, this is the direction of his left hand, and north pole is moving towards left hand. Okay, understood? In this figure also the person is swimming, but the person is swimming in the direction of again electric current. The person is swimming this direction now, this direction. So where is his left hand? This is his left hand. Okay, oh sorry, this is his left hand. So north pole is moving towards left hand. Understood? Means the person is swimming like this, and this is left hand. So north pole will move towards left hand. Okay. So this is the direction of the motion of the magnet. So I repeat, what is Ampere swimming rule? In Ampere swimming rule, a person is swimming in the direction of electric current, and the north pole of the magnet will move towards left hand of the swimmer. Understood? So now write it. According to Ampere swimming rule, according to Ampere swimming rule, a person is swimming in the direction of electric current. A person is swimming in the direction of electric current, and the north pole of the magnet and the north pole of the magnet will move will move towards the towards the towards the left hand of the swimmer, towards the left hand of the swimmer. Finished. Understood this? Okay. Now, one question for you. When you are passing electricity through it, okay, or this is the magnet, okay. Now, just above this magnet, when you are placing the wire, then it doesn't affect the magnet, okay. This is the magnet and this is the wire, okay. This is the wire. When you are placing the wire just above the magnet like this, just above the magnet, then the magnet doesn't behave in any way. But the moment you pass electricity through this wire, okay, the moment you pass electricity through this wire, the magnet rotates like this, okay. The magnet rotates like this. Now the question is why the magnet rotates like this? Let's see. You write in the comment. Let's see why the magnet rotates. You write in the comment. Why the magnet is rotated? Let's see what are the answer. Uh, 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 One student, sir, magnetic lines are created due to which the magnet rotates. Magnetic lines are created. Whose magnetic lines are created? That magnets, na? That magnet which you have taken, that magnet's magnetic lines are created. Okay, one more answer, sir. Because who is this student? Sir, amigo, I am not able to understand. Just mention the name. Sir, because when no current is passed, then the magnetic field pass within the wire, and when the current is passed it opposite the, okay, this is Alex. Current is passed it opposite the magnet, oppose the magnetic field from passing within it, so magnet changes its direction. You have gone so far. What is the basic idea? The basic idea is, okay, let me tell you why the magnet was behaving like this on passing electricity through this wire. What is the reason? The main reason is, when you are passing electricity through the wire also behaving like a magnet, okay. The wire behaving like a magnet. Yes, this is my magnet which I have taken, and just above this magnet I have taken a wire, simple wire. This is the wire, and I am passing electricity through this wire. So when you are passing electricity through this wire, then this wire also becomes a magnet. Understood? The wire changes in a magnet. This is true. We know that from our junior classes like 7, 8. We have seen that when say a iron rod, you know electromagnet, a iron rod, when you turn this iron rod by using wire and you pass electricity through that wire, this rod becomes a magnet. Yes, when you pass electricity through your wire, that wire behaves like a magnet. Understood? All the connecting wire of your home, which are connecting the fan, your refrigerator, washing machine, okay, your induction cooker, your AC, means all the devices. To connect all the devices, you require wire. By connecting wire, those wires, when you are passing electricity through the wire, that wire behaves like a magnet. Understood? The wire behaves like a magnet. So this is the main reason here, that this is the magnet and this is the wire. So when you are passing electricity through this wire, the magnet rotates like this or like this. Okay. So I told you, when you pass electricity through a wire, the wire behaves like a magnet. Fine. I repeat, when electricity is passing through a wire, the wire behaves like a magnet. And that day I told you, a magnet is there means magnetic lines of force are also there. Understood? So today I told you, a wire, when current is passing, the wire behaves like a magnet. And number two, that day I told you that a magnet is there means magnetic fields are also there. Okay. So I can tell you that to find that magnetic lines of force, the technique is very easy. You remember that day I told you that to find the magnetic lines of force, we will take the gunpowder or the iron fillings, powder iron. Then the iron will spread and will shake the board. Then we'll see a particular format. The same experiment will do. Okay, but here we'll not take a magnet, we'll take a wire. Okay, wire, current passing wire. How will you take it? Say this is the page. Understood? Here we'll make a hole. Here we'll make a hole, and the hole, through that hole, one wire will be passed through. Okay, and this is the wire. Understood? I'm saying you. See, first I'll take a cardboard. See, this is the cardboard I'm taking, and wire is passing. See, try to understand this figure. This is the cardboard and this is the wire I'm passing. Okay, understood? Now, through that wire, through this wire, I will pass electricity. Through this wire, I'm passing electricity. See, direction of electricity is upward. Direction of electricity is upward. Okay. Now what I'm doing, I will take iron fillings, and iron fillings I'll spread on the board. This board, iron fillings I will spread. Okay. Iron fillings. You know iron fillings? We have discussed that powdered iron. That is iron, but in the form of powder. So I will spread it here. After that, I will shake the board. This board I'll touch and I will shake the board. Okay. I will see that it is making a particular format like this. This is very important what we are discussing now. It will make a particular format like this. See. Okay, like this. Particular format. Understood? So we can say that this are magnetic lines of force. Okay, these are magnetic lines of force. Now, these magnetic lines of force are in the form of, what is the shape of this? Triangle or square? Yes, these are circle. So, the magnetic lines of force are in the form of circles. Now, if I ask you how many circles are forming, then you will say that 1, 2, 3 circles are forming. No, not 3. Infinity number of circles are forming here. Okay, number of circles will form, not 3. Here I have drawn 3, but number of circles will be infinity. Understood? And all the circles are concentric circle. Why concentric? Because all the circles center are same. Just see, all the circles center are same center, and through that center only the wire is passing. Okay, through that wire, center only wire is passing. So we know three properties now. Three properties. The first property is magnetic lines of force are circular. Here, okay, here magnetic lines of force are circular. Okay, circular. Number B, they are in the form of concentric circle. They are in the form of concentric circle. Concentric circle means they have got same center. Okay. Number 3, the wire is passing through the center of those circles. The wire is passing through the center of those circles. Okay. Number 4, the direction of magnetic lines of force. Yeah, a direction is also there. We have discussed in previous day. We have discussed that the last class we discussed the direction of magnetic lines of force is always from north pole to south pole. So here also a direction should be there. Where is that direction? To find out the direction, we'll use right hand thumb rule. This is thumb, right hand. See my right hand thumb rule. This is the way you have to keep. Okay, this is the way you have to keep. Right hand thumb rule. Now how will you decide? This is thumb. It is showing you the direction of electric current. Okay, this thumb is showing you the direction of electric current, and other finger will show you the direction of magnetic lines of force. Very simple. This is thumb, direction of electric current. Other finger, okay, other fingers showing you the direction of magnetic lines of force. See this way. Okay, this way you have to keep. Understood? See the way I'm keeping. This way you have to keep. Okay, this way. So same here. If you apply this is the direction of electric current. See, upward, upward, the direction of electric current. And other finger, it's this way. Okay, so this way. That means, see, I've given the direction also. If you can see, I've given the direction also. Okay, this is the direction. This is the direction. See. Okay. Actually, this one, if I see it from up, if you see from up, then what is the direction of it? Anti-clockwise, no? The direction of is anti-clockwise. Just see. Yes, anti-clockwise. So the same way, see here, the direction is anti-clockwise. Okay. Understood? Direction is anti-clockwise. Fine. So by using right hand thumb rule, we can find out the direction of magnetic lines of force. By using right hand thumb rule, we can find the direction of magnetic lines of force. So now what is the question of it? Write down the question. This one. Write down the question. Start. Write the properties of of magnetic lines of force, magnetic lines of force for a straight current carrying conductor, for a straight current carrying conductor. Okay, write down the properties of magnetic lines of force for a straight current carrying conductor. Straight, because this is a straight wire, straight wire, straight current carrying conductor. Okay, now write. First of all, you draw this figure. Draw the figure. Fast. This arrow also you must give, huh? This arrow also you must give. Okay. So, now write properties. So, what is the question? The question is the properties of magnetic lines of force for a straight current carrying conductor. Important question. So, property. First property, number A. Number A. The magnetic lines of force, the magnetic lines of force are in the form of, are in the form of some concentric circles, some concentric circles. Concentric circles means the circles with same center. Okay, the circle with same center. Number B. Number B. The straight electric wire, the straight electric wire is passing through, the straight electric wire is passing through the center of those circles, the center of those circles. Okay, understood? Center of those circles. Number C. Number C. The direction of magnetic lines of force, the direction of magnetic lines of force, understood? The direction of magnetic lines of force is shown in the figure, is shown in the figure. You must have drawn this figure and you have shown the direction also, is shown in the figure. And this direction, and this direction can be determined by, and this direction can be determined by Ampere's swimming rule. Sorry, can be determined by right hand thumb rule. Okay, we discussed this. Right hand thumb rule. Fine. Okay. So I hope you understood this figure. Okay. Understood this figure. So what was the question? The question was write the properties of magnetic lines of force for a straight current carrying conductor. Okay, straight current carrying conductor. This was the property. So we'll finish our class here. In next class, next means Wednesday 8 o'clock. Wednesday 8 o'clock we'll have another live class. because Wednesday will have another live class, because Thursday will have your test. Okay, that is CP plus performance. CP1, 10 marks. That is on Thursday. Fine. And what is the syllabus? Syllabus is what we are discussing through these live classes of the chapter electromagnetism. Today we have finished till straight current carrying conductor. Next day we'll discuss more. So whatever we have discussed from this chapter, I'm not saying the whole chapter, how much we will be able to finish by this Wednesday of this chapter, that much will be the syllabus of CP1, which will be conducted on this Thursday. I think 12 o'clock is your class, physics class. So in that class, okay. And the way of conducting the test is same as I have conducted in UT1. Acha, Pratham has sent the message. Let's see. Sir, today I was there throughout the class. Very good. Yeah, you should. And Pratham, tell me, you understood whatever we discussed? Just answer me. Just answer me if you all have understood. Yes, sir. Very good. Very good. Very good. So I think if you attend, then you will understand the class. No? If you attend, then you will understand the class. Fine. Okay, so let us bind up the class. But before binding up the class, I will say start. And after that, you will start writing your name once. Okay, name your once. Start. Yes, Pratham is saying, sir, these days network are working good. Yes, network are working good. Okay, I can see Sneha, Shahil, Saksham, Sneha, Amisha, Maitri, Alex, Suprabhatam, Tapabrata, Pratham, Namrata, Nilesh, Priyansh, Raman, Pragyan, Kesang, Subhama, Aryan, Mritik, Sudipa, Jasraj, Shreya Kumai, Avinay Vujel. Okay. So fine. So let us finish the class. Rohit Prasad. Okay. So let us finish the class here. Wednesday we'll have another live class, and after that Thursday we'll have test CP1. Understood? So see you on Wednesday first period. Okay. Thank you.